Let's look at the first method to solve non-homogeneous equations. It's the method of undetermined coefficients. So we want to find any solution to y second plus function of t y prime plus function of t y equals function of t. And our first step is to say that this is too hard, and we're going to solve for actually y second plus a y prime plus by equals g of t. So we went from a general second-order linear ODE to a constant coefficient second-order ODE. And our first example is going to be y second minus 3y prime minus 4y equals 3 exponential of 2t. If we look at this, we know how to solve the homogeneous situation, but the non-homogeneous is outside of our knowledge at the moment. But we can look at it with a lot of attention, I would say. And we remember that derivatives of the exponential of something times t are something times the same exponential. So we guess that one specific solution, one particular solution of our non-homogeneous ODE is a constant times exponential of 2t. And our goal now is to find the constant in front of this exponential. We can compute easily the first and second derivative of y. The first derivative of y is 2 times y. The second derivative of y is 4 times y. And we plug this information inside our ODE. So we have our ODE, non-homogeneous, a first guess of a solution, and we try to max it in. So we plug it in. We see that including the non-homogeneous term, everything has the term exponential of 2t. So with some reshuffling, we can take the exponential of 2t away, and we can solve for the coefficient in front. So c is minus 3 divided by 6. That simplifies as minus 1/2. So we have immediately, just by taking a guess that had some reasons to be there, but it was pretty much a guess, plugging it in the non-homogeneous ODE, and we're able to find the coefficient in front of that guess and have one specific solution, one particular solution of the non-homogeneous ODE. That means that the general solution, any solution of the non-homogeneous ODE, has the form of the particular solution that we just found plus the homogeneous solution, the solution of the homogeneous ODE associated to this ODE. So any solution that we want to write to y second minus 3y prime minus 4y equals 3 exponential of 2t has the form minus 1/2 exponential of 2t plus the general solution of the homogeneous system. Let's look at another example. In this case, we have y second plus 3y prime minus 5y equals sine of 2t. And the question we want to answer is, if we have a function, when can we have sine of 2t appearing as the derivative of this function? So the second derivative of sine of 2t is minus 4 sine of 2t. So sine of 2t is one of these possible functions that has sine of 2t as its derivative. We also know that the derivative of cosine is minus the sine. So cosine of 2t, the first derivative of that, is minus 2 sine of 2t. So we want cosine in the pool of possibilities of our solution of this non-homogeneous ODE. Also, sine of 2t, the zeroth derivative of that, is sine 2t, so we want sine of 2t. So our guess is that our particular solution to this non-homogeneous ODE is the sum between sine and cosine. we need to keep coefficients, so we guess that capital Y is equal to A sine 2t plus B cos 2t. And we take derivatives, so Y equals A sine 2t plus B cos 2t. Y prime is 2A cos 2t minus 2B sine 2t, and Y second is minus 4A sine 2t minus 4B cos 2t. We take our non-homogeneous ODE back, so Y second plus 3Y prime minus 5Y equals sine of 2t, and we plug this information inside. And the first version, we just plug it in straight away. We have minus 4a sine of 2t minus 4b cos of 2t plus 3y prime, that is minus 2a cos 2t minus 2b sine of 2t minus 5y, so minus 5a sine 2t plus b cos 2t equals sine of 2t. We solve things around, and we have on the left hand side a linear combination of sines and cosines, and on the right we have a known combination of sines and cosines. So we untangle sine and cosine. You have to think of the fact that sines and cosines depend on t. So if they need to match, that means that all the sines need to match and all the cosines need to match. So we disentangle this one equation into two equations that have all the coefficients of the sine on one equation and all the coefficients of the cosine on the other equation. So in this case, we have minus 4a sine of 2t minus 6b sine of 2t minus 5a sine of 2t equals sine of 2t, and we simplified sine of 2t away. And on the other, we have minus 4b cos 2t plus 6a cos 2t minus 5b cos 2t equals to 0. So now we have two equations in A and B, and we can solve for them. So we have A equal to minus 1/5, B equal to minus 2/15. So the particular solution of our non-homogeneous ODE is minus 1/5 sine 2t minus 2/15 cos of 2t. Remember that the general solution is the sum of the particular solution plus the general solution of the homogeneous equation. So the next question is, what happens when we have products? Now we have y second plus 3y prime minus 5y equal 6 exponential of 2t cos of 2t. What do we expect? Well, we expect something that is exponential of 2t multiplied by something, because that is the only thing that will give us the exponential of 2t. We also expect a linear combination of sine t and cosine t. So we're going to multiply these together. And we say that our guess solution is exponential of 2t multiplied by a sine t plus b cos t. And then we can take the derivatives. So we take the first derivative and we take the second derivative. The second derivative is quite cumbersome, but we rewrite it in a simpler way. And you notice how the y is e to the 2t times a combination of sine and cosine. Y prime is e at the power 2t times a combination of sine and cosine. And y second is e to the 2t times a combination of sine and cosine. So they have the same structure. The only thing that changed is the coefficient in front of sine and the cosine. So now we take all this information and we plug it into the ODE that we have. And this might look messy, but you have to look at the general structure that it has. We have e to the 2t appearing everywhere. Everything else is sine and cosines, a's and b's. So we can simplify things around, and as before, we want to group all the sines on one equation and all the cosines on the other equation. So we have one equation for the sines that require us to have a minus 8b plus 3 times 2a minus b minus 5a equal to 0. And we have the other equation being 5a plus b plus 6 2b plus a minus 5b equal to 6. And we can solve for this, and we find a specific value for b, that is 12 divided 24 plus 11 to the square, and a specific value for a, that is minus 11 divided by 2 times b. So we have found that our guess worked. Sorry about that. So we have, I'm not going to write the coefficients back again, but our guess that the particular solution of a non-homogeneous ODE in which the non-homogeneous term is a product of sine and cosine times exponential is, as a guess, we used the exponential times sine and cosine, and that worked out. We could find the coefficients fitting that. Let's look to a new example. We have y second plus 3y prime minus 5y equals 6 exponential of 2t cos t plus sine of 2t. If you look at the right-hand side, this is a sum of the previous right-hand sides that we chose in the last two examples. In example 3, we had y second plus 3y prime minus 5y equals 6 exponential of 2t cos t, and we called that solution y1. And in example 2, we had the same left-hand side, and as a right-hand side, we had sine of 2t, and we call the solution of the example 2 y2. Then the solution of this last example is the sum of these two solutions, y1 plus y2. Let's give an overview. If our right-hand side had either sine of at or cosine of at, then our guess is a linear combination of sine of at and cosine of at. If our right-hand side had exponential of something times b, our guess is coefficient times the same exponential of bt. If our left-hand side is a polynomial of grade n, our guess is a polynomial of grade n with different coefficients, so we have to track every single coefficient. If our right-hand side is a sum of two parts, then the solution is the sum of the two particular solutions. If it's the product, then the guess that we have to do is the product of two guesses. Let's look at another example. We have y second plus y equals sine of t. And as we did before, we guessed that our solution should be a linear combination of sine and cosine. So we have y equals a cos t plus b sin t. We have y second, that is minus a cos t minus b sin t. And we plug that into our equation, y second plus y. And we retrieve that if we plug that in the left-hand side, then we return 0. And 0 cannot be equal to sine of t. So we don't have any choice of capital A and capital B to make this work. That's unfortunate. Why is this happening? It is happening because c1 cos t plus c2 cos t is the general solution of the associated homogeneous ODE. So we're trying to solve non-homogeneous ODE, but we're plugging in the solution of the homogeneous ODE. That means that we have just no hope of having a combination of sine and cosine with just straight coefficients in front that would satisfy the non-homogeneous ODE. How are we supposed to do in this situation? In this situation, we multiply our guess solution by t. So instead of trying a sin t plus b cos t, we try t multiplied a sin t plus b cos t. Why? The reason, even though I'm not going to go into detail to explain why, is the same that allowed us to solve for repeated roots. When we were solving for repeated roots in the characteristic equation of a linear constant coefficient ODE, we had also this t popping up in the solutions. This is a similar process. So now we have y equals t times a sin t plus b cos t. We have a formula for y prime that is a sin t plus b cos t plus t a cos t minus b sin t, and a formula for y second that is 2a cos t minus 2b sin t minus t a sin t plus b cos t. And we plug that into our ODE. The ODE is y second minus y. And if we calculate this and we plug it equal to sine of t, that is the right hand side that we want to solve for, we retrieve something that fits. We retrieve that a is equal to 0 and b is equal to minus 1/2. So we have a guess for our solution, for our particular solution, that is minus 1/2 t cos t. And if we combine this guess with the the general solution of the homogeneous equation, then we have the general solution of the non-homogeneous equation. So as a rule, if G, so our right-hand side is a linear combination of the fundamental solutions of your homogeneous ODE, you guess your solution by multiplying by t.